Hyperbolas. In this section we will look at one type of hyperbola, the rectangular hyperbola. Specifically we will look at functions of the form y equals a over x minus b. A bit later on we're going to put a plus c here as well, but not initially. Where a and b are constants. The simplest member of the family is y equals 1 over x, the graph of which is shown below. So this is the graph of y equals 1 over x. You can find some points on here like 1, 1, because we know that if x is 1, 1 divided by 1 is 1, so the y-coordinate is 1. And then this point here would be at 2 1/2, because 1 divided by 2 is 1/2, and so on. The reason this type of hyperbola is called rectangular is because in this particular case we can see the y-axis and the x-axis are both asymptotes of the curve and they meet at right angles. So it's called a rectangular hyperbola. You can get other types of hyperbolas that fit into shapes like this. You can also get rectangular hyperbolas that don't fit along the axis but are also rectangular, like so. But we're only going to deal with this type where the axes, or at least horizontal and vertical lines, are the asymptotes. So as mentioned, the x-axis and the y-axis are asymptotes of the curve. The asymptotes cross at the origin. We know that this is y equals 1 over x. We said that that was that graph. And what I'm going to do is I'm just going to zoom in at the origin. So this is part of the curve here, and this is 1, 1. So you can see the extent to which we zoomed in if we knit back up and just look at where 1, 1 is here. So we've zoomed in a sort of square region around here. If you go to where the asymptotes cross and go 1 unit across, and then see what you need to do to get to the curve, in this case we go 1 unit up, it gives you the value 1. So if we'd had y equals 2 over x, that would have actually gone through the point 1, 2 here, and then by going 1 unit to the right from where the asymptotes cross, we'd have had to go up 2 units. So the method shown can always be used to identify the a in y equals a over x minus b. Just go to the point where the asymptotes cross, go 1 unit to the right and see what you must do to get back to the curve. If you need to go upwards, then the number is positive, as it was in the examples I gave of 2 and of course the example we already had of 1. And if you go downwards, a would be negative.